this is a lesson on kites. There's no section in the book that deals with this, but the idea of kites is kind of still a special quadrilateral. It has some special properties, but you'll notice just even in this diagram here that these two sides are not parallel to the sides that are across from them. So that's kind of the key thing that separates the idea of a trapezoid or even parallelograms, rectangles, rhombuses, and squares, is the fact that there's no parallel sides involved here. Okay, so we're going to talk about three special properties that deal with kites. The first thing is that the diagonals of a kite are perpendicular, which is very similar to a rhombus. Two pairs of consecutive sides are congruent, and opposite sides are not congruent. When we talk about the second one right here, when we say two pairs of consecutive sides are congruent, it's saying that this and this are congruent, and then this and this. Consecutive meaning right after each other or connected to each other or adjacent to each other. And so the idea is that the top part of the kite is congruent, the bottom part of the kite is congruent, and because these are right angles, we can then say, okay, this is going to be able to help us solve to find out what these different pieces are. You could also mark in your diagram, or if you want to put this into your notes, that this piece right here and this piece right here are also going to be congruent. The top part, the little piece up here, and the bottom part down here are not going to be congruent to each other. And you can see that just by looking at it, it's kind of bottom heavy right here, and it's not really that kind of long up top. So really these three properties over here on the left-hand side, or up top I should say here, are really the only three properties we know about a kite, and we're just going to add in this extra little piece saying part 3 and part 3 are going to be congruent to each other as well. All right, at this point, you should have every single piece of your quadrigraphic organizer completed. All right, the idea of parallelograms with 6 pieces in here, and I only have 5 of them. This is an old one. You have rectangle and rhombus and square, and you have your new pieces for trapezoids and the extra piece for isosceles trapezoids, and now 3 pieces for your kites. And we can now take and apply that to some application problems that deal with kites. And I think there's a couple problems here. For the first one, it says, okay, find the measures of angle 1 and 2. What we want to recognize here is that this is an isosceles triangle. And because this is an isosceles triangle, if you flip this over, this and this are going to be congruent together. Because the sides are congruent, the base angles are congruent. Angle 2 is going to be equal to 22 degrees. Angle 1, my hope is that you recognize that all of these are always perpendicular because one of them is, therefore all of them are. But angle 1 is going to be equal to 90 degrees. The next diagram down here says find the measure of angle 1, 2, and 3. Okay, the first part, that's 90, that's pretty simple. Because this is 45 right here, we can say that angle 1 plus 45 plus angle 2 would be equal to 180. And we know that angle 1 is going to be 90. So now the idea is just to find what angle 2 is. When you do the math here, you find out that it's going to be 45 degrees. Because this is 45, this has been bisected up here, so this angle 3 is also going to be 45 degrees. And if you scroll back up with me and just kind of follow along in this video, we didn't really notate this, but this and this are going to be congruent to each other, and this are going to be congruent to each other. The reason that's the case is that you have this triangle here with a shared side congruent to this triangle here with a shared side. And so by SSS, these two triangles we just outlined are congruent, therefore their corresponding parts are congruent, and we can have congruent angles there. Alright, so let's take a look down here. Find the measure, and disregard this stuff down here. Don't need to worry about this. Okay, find the measure of all the unknown angles. So it's giving you 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. It's only giving you 2 little pieces, 34 and 46. Alright, what you should immediately recognize is that 5 is going to be 46 and 6 is going to be 34 because these angles have been bisected. 1, 2, 3, and 4 are all going to be 90. And then once you have that, you'll notice that every single triangle that you look at, you now have 2 of the angles. You just have to find the missing piece. So if this is 46 and this is 90, and we want to find out what 10 is, we can find out that 10 is going to be 44 degrees. 8 is going to be 44 degrees. 7 and 9, again, we're looking for these triangles, so let's look at 9 here. We know the angle's 34, we know 90, and we're looking for 9. Again, just subtract those from 180, and you'll find out that it's going to be 56 for 9, and therefore 7 is going to be 56. The idea behind this is really not that we're creating congruent sides, but really more about finding missing angles. You'll notice 9 and 10 and 7 and 8, when you look at those together, those are actually going to be congruent to each other. Right? The sum of 9 and 10, the sum of 7 and 8, actually 9 and 7 are the same, and 10 and 8 are the same. And so we're going to work more tomorrow with the idea of kites. We're going to have some practice stuff in class to have you test and be able to find out what all the different angles are. To be able to see, can you understand what the different diagonals are doing because they're at right angles? How does this help us be able to find missing angles?